Hello, hello. So, how's everybody doing? Let's get into this story because I'm just talking to myself otherwise. Physicists discover time can flow both ways in materials. Oh, time is bisexual, you say. Time seems to flow in one direction for us. We never see a broken glass reassemble itself on the floor. You don't say. But physicists, this is not, but for physicists, this is not so obvious. The equations that describe motion work both ways in time. For example, a video of a swinging pendulum would look the same if you played it backwards. Yeah, because it's going back and forth. If you're repeating an action and you played that action backwards, you're still repeating an action. But if you labeled one point and the other, and one point says two, the other one says one, and you play it backwards, it wouldn't look the same. Ah, we see time as irreversible because of another law of nature, the second law of thermodynamics. This law says that the disorder in a system always increases. If the broken glass reassembled itself, the disorder would decrease. All right. Gotcha. The same law applies to the aging of materials, but physicists from Darmstadt have found out that this is not the case. They have discovered that the motion of molecules in glass or plastic can be reversed in time if you look at it from a special angle. So it's a matter of perspective. This doesn't sound very scientific. The team led by Till Boehmer at the Institute for Condensed Matter Physics at the Technical University of Darmstadt have published the results in Nature Physics. The eternal clock of glass. Glass or plastic is made of tangled network of molecules, and these molecules are constantly moving and changing their positions. They are always looking for a lower energy state, which affects the material's properties over time. The glass ages. But this process can take billions of years for some materials like window glass. The aging process can be described by material time. Think of it like this. The material has a clock that ticks differently from the clock on the wall. The material time ticks faster or slower depending on how fast the molecules in the material are rearranged. This concept was proposed about 50,000 years ago, but it has been a while since anyone can measure material time. The researchers in Darmstadt led blah, 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 blah. Um, what I'm what I'm thinking at the moment is that what they're seeing is that they're merely measuring the signs of aging. For instance, some people would say, "Oh, this lady looks very young for her age." But what is in fact they're observing is that the signs of aging is not as obvious on this woman as opposed to other women around her age. So they're measuring the signs of aging, not the actual aging. So you're not recording time, you're simply recording your perception of time. If you perceive this change to happen at this time, and if you don't see that certain change at that time, then you would assume that the time didn't pass, right? Either the time didn't pass or something else happened. So it's not a matter of material time being different. It's just a matter of what they're observing and their limited ability to observe things properly. A surprising discovery. It was a huge experimental challenge, says Boehmer. The tiny movements of the molecules had to be recorded with a very sensitive video camera. You can't just watch the molecules jiggle around. Well, hopefully no one rewound the footage on you. But they did see something. They shone a laser on the glass sample. The molecules in the glass scattered the light, and the scattered light beams overlapped and created a random pattern of bright and dark spots on the camera sensor. Using statistical methods, they could calculate how the pattern changed over time. This told them how fast the material's internal clock was ticking. This required extremely precise measurements that were only possible with the latest video cameras. Okay, so is it possible that's even within the same material, they don't all age at the same speed. As he's saying, the molecules are moving at different speeds and they're constantly changing. So one piece of glass could age faster than another piece of glass simply because the molecules just rapidly moved in a certain way that just speed up the process. The results were surprising. With the help of researchers from Roskilde University in Denmark, they analyzed the molecular movements regarding material time. They found that these movements were time reversible. This means that they would look the same if the material time ran backwards, like the pendulum video. However, this does not mean that the aging of materials can be reversed, obviously. Stresses Boehmer. Rather, the result shows that the concept of material time is a good way to capture the irreversible part of the aging of the material. Its ticking represents the passage of time for the material itself. What does it mean? The researchers also found that only some things moving in the material contribute to aging. Okay. Only the movements that are related to the material time matter, obviously. To illustrate this, they used a metaphor. Children playing around in the back seat of a car do not affect its motion. Yes. This is not as complicated as they believe it to be. I don't understand why they're giving so many examples. Donstad researchers believe this finding applies to all disordered materials, not just glass or plastic. They tested this hypothesis by examining two classes of material and simulating a model material on the computer. They got the same results in all cases. The physicists' success is just the beginning. What did they succeed at? They found proof of something that anyone reasonable could have come to this exact same conclusion. It's not progress. This leaves us with a mountain of unanswered questions, says Blochowicz. Okay, for example, they want to know how the reversibility of material time is related to the reversibility of the physical laws of nature. Well, if you don't have a way to reverse the actual thing rather than just a video of the thing, you have found nothing. You found out that video can go in reverse. Like, I think there's a lot of to say about scientists, and a lot of their discoveries rely on actual testable information, right? So even if something is reasonable and it's obvious to conclude, they still have to be able to prove it in a testable physical way that anyone could do, and it can actually be verified. Because of that fact, they tend to come out with nonsense that means nothing and doesn't create progress. But because they can now prove something that was very obvious and it can be verified, now it's goddamn progress. It's silly. It's beyond silly, and people need to tell them to stop publishing shit that we already know. The researchers are eager to explore more so that we can expect more. I don't expect anything from you. You might freaking prove that water is wet or something. Anyways, until next time.